As we continue graphing polynomials, what we're going to do is we're going to try to make some more generalizations as we kind of did from our example one. And they're all kind of in this particular form where you have some type of set of parentheses and the power is going to be 3, 4, 5. It could be anything really. But we're going to be focusing on these particular values right here. So like we're going to be focusing on this first coefficient, the value that comes after like x, and then if there's a value out here. And so basically there's some really neat things that happen when you look at graphs of that form. So if we just look generally, and we're just going to use letters now, if I said a times x minus h to the power of n plus k, we're going to just look at what does a do to our graph? What does the h do to the graph, and what does k do? And actually, from our last example in a, we learned about that, right? If we look right here, we learned that the a stretches the graph vertically, making it more narrow, and the a is going to shrink the graph. So we're going to see that right now. And so what I've done is, using Desmos, I've just kind of punched that same thing in, and it's really cool. They create these sliders that allows you to play with them. And so right now I'm just going to make k 0 right now, okay, and I'm going to make my h 0 as well. So basically this right here is just f of x equals to a times x to the power of 7, which is now our basic graph right here, right? And so we learned that as a gets bigger and bigger, it gets narrower and more narrow, right? So, I mean, look, if it's in the 70s, 80s, 90s, it's getting more narrow. And then, of course, if you make it really small, it's going to get super wide, right? So we know that from our last example. But now, what happens when we put in this h? What does this h do to our graph? So what I'm going to do right now is I'm just going to slide this back and forth. And let's see what happens with h. Kind of obvious, right? We can see that the h is a vertical shift. That's all h does to our graph. It just shifts the same monomial graph left to right, horizontally. Pretty cool that, right? And then, if I put that back at 0 there, what did I do there? Let's add that back in. So now, if we slide k back and forth, let's see what that does to our graph. And as you can see here, it's sliding the graph vertically up and down. So we have this thing going on right here. We have k shifts it vertically up and down, h shifts the graph left and right, and then a stretches it vertically or it stretches it like horizontally, depending if it's some kind of fraction. Okay, so those are like the general rules right there. If you want to kind of know what are the different things doing to the graph, and I suggest that you go on Desmos yourself and go check it out. It's actually a lot of fun. So just generally now speaking, for some of our, I guess you could say, just general rules here is the following. We know that negative a x to the power of n is a reflection across the x-axis, and that's what we saw from our first example. The graph now, right, k, we just saw right now that k translates or shifts the graph up and down, right? It's a vertical shift. So it shifts it up if it's positive and shifts it down if it's negative. And we also learned about h, right? H, it shifts it left and right. So here, if h is greater than 0, it's going to shift to the right, and it's going to shift to the left if h is less than 0. Okay. And then lastly, you can kind of combine them now, right? You can do a vertical shift and a horizontal shift and a stretch all at the same time, and we can kind of know what's going on right there.